Students, welcome back. We had been somewhere here like this, and we were trying to understand why this summation, which here starts from 0 to infinity, it can also be written as it starts from 2 to infinity, and the same for this one, and for this one it should start from 1 to infinity. So carrying on with this, we can write it like this. That implies n goes from 2 to infinity, n minus 1 Cn x to the power n, plus again the second term also we can write in the same manner, from 2 to infinity n minus 1 Cn. The only difference between the first and the second term is that in the second term the power of x is diminished by 2. Then again this one can be written as n goes from 1 to infinity n Cn x to the power n minus n goes from 0 to infinity Cn x to the power n plus 1, which is equal to 0. Now students, we are going to do something here. We will, in the next step, we'll try to make all the powers x to the power n. You must remember that this is not just an expression n minus 1 Cn x to the power n. This is a whole infinite series. Each of them, they are infinite series, though, so that we will have so many terms. And you see here, when I put 2, this starts from x square. This one starts from x to the power. When I put 2, this becomes x0, and so on. So you see, things are like this. So let us now try to make them x to the power n. So the first term already, it is, the power is x to the power of x is n. So we don't have to do anything to change this. We keep it as it is. So 2 to infinity n minus 1 Cn x to the power n. Now look at this. Can this not be written as, again we come to explaining term by term, this one, can this not be written like this, as n, to make this x to the power n minus 2 as n, just x to the power n, that means n minus 2, if has to become n, then what will happen to this 2 here? The 2, will it not start from 0? Because you see, take to that side, this is, or you can write it as, so n minus 2 has become n, or will become n in the next term. So if it becomes 2, so the term must remain same. That means when I open it, we can look at the first term. Look at the first term, what it is? N is going from 2, so the first term becomes 2, 2 minus 1, that is 1. When I put n is equal to 2, this becomes 2 into 1 into C2 into x to the power n. Sorry, I am looking at this, so 2, this becomes n minus 2, that means 2 minus 2, which is equal to x to the power 0. Now, if I want this to be x to the power n, then obviously the first term will have to start from n is equal to 0. So if I have to put here x to the power n, how the other things will change? Let us see. So obviously the other things will change in a similar manner, and what we get is, here should be Cn plus 2 here, instead of n, we will have n plus 2 here, and then instead of n minus 2 we have n. That means this is 2 more than that, so this was n, this must become n plus 2, and here, but for the term to remain the same, I must start from n is equal to 0. So when I put n is equal to 0, what is the first term here? To see this, what we'll do is we'll just write it and see if both of it gives the same expression or not. Let us see. So let me first clean my board like this. So students, in each of these numericals in power series, you will come and you will stumble here actually when you have to say change the power of x. So if you do 3-4 numericals, after that only things will become clearer to you why you are doing it and all these things. So let me just write it like this. This is going from n is equal to 0 to infinity. This becomes n plus 2 into n plus 1 x to the power n. So you see, everywhere what I have done is I have put x, I have put changed the value of n by 2. I have increased it by 2 in the second expression. Yeah, here it was x to the power n minus 2. So when I add plus 2, this becomes x to the power n. Here it was n, so n plus 2 comes here instead of n, and instead of n minus 1, n plus 2 minus 1 is n plus 1. So it comes like this. But what about the summation? Summation I have decreased by 2. Why? Because otherwise this would have started from a different term. Now look at the two terms, the starting part by part. If you open this and you open this, you will find that they actually mean the same series. Here, look at what is the series. Here the series is, when I write 2, n is equal to 2, I am opening this, okay. So I am opening this one. So what I get? I get the first term as 2 into 2 minus 1, that is 1 into what is Cn C2. Then I forgot to put the Cn plus 1, n plus 2 here. We had Cn, I should have Cn plus 2 here. So it will come like this. So this is like this. We reached till here. Then x to the power n minus 2 becomes 2 minus 2 is 0. Now let us look at the first term of this series, what it is. The first term of this series, if I put like this, n is equal to 0, this becomes 2. When I put n is equal to 0 here, this becomes 1. Cn plus 2, this becomes, when I put like this becomes C2. And when I put x to the power 0, x to the power n 0, this is x0. You see, both of them are matching. This is only about the first, not only about the first term. So if I open this one by one, the series that I get is the same when I open this one by one, putting n is equal to 0, infinity, infinity. So why we are doing this is because we want to take x to the power n common. That's why. So that's why this is how we'll again go to the next one, the next term. So let me write this in a proper manner. So I will write this Cn plus 2 in front. This is Cn plus 2 into this. Now coming to the next term. Next term is x to the power n. So we don't have to do any change here. So this summation change thing and changing the n is equal to this term, this one, don't be confused by the first time we did it. First time we did it because the first two terms were just 0. So after this we come to this, we write this as just n goes from 1 to infinity, n Cn x to the power n, because I don't have to change it here. This is x to the power n, this is x to the power, this is x to the power n. But this one, you see, here it was 2 less, here it is 1 more. So let us see how do I change it. Here what did I do? In order to this, I'll have to decrease it by 1. So I have to increase the summation by 1. N was equal to 0. Now it will start from n is equal to 1. So n is equal to 1. N is equal to 1. Sorry, n is equal to 1, and this becomes how much? Ncn minus 1 x to the power n up to infinity. So this is how we change this, and please note down this very carefully, because we will be equating coefficients from both sides here. So take care that you make no mistakes here. So n is going from 0 to infinity, and this is c to the power cn plus 2. So this is the expression, and let us go to the next part now. This implies n goes from 2 to infinity, n minus 1. So we are not changing this in any way. Cn x to the power n plus let us look at this one. When I put n is equal to 0, what do I get here? When I put n is equal to 0 here, n is equal to 0, this becomes C2. Is it not? C2, and then how much? Into 2 into 0 into 1 into x to the power 0, which is just 0. I am opening this summation, okay, term by term. N is equal to 0 I put, then I put n is equal to 1. When I put n is equal to 1, what do I get? I get this as C, 1 plus 2 is 3, 1 plus 2 is into 3 plus 1 plus 1 is, or not plus, this should be multiplied by 2, like this, x to the power, this time because I am putting n is equal to 1, this is 1. So we do this. So what did we do? We took the n is equal to 0 value. We had the whole value from n is equal to 0 to infinity. So this is n is equal to 0, then n is equal to 1 also we took. This is the value for n is equal to 0 of this expression. This one is for n is equal to 1. Now the rest I put in a summation sign. So it is n is equal to 2 to infinity Cn plus 2 n plus 2 multiplied by n plus 1 into x to the power n. So this is multiplied by n plus 1. So here what do we do? Here we can do one thing. We can take the summation as going from, first we put n is equal to 1. So what do I get? Plus n is equal to 1. When I put here, this is 1 into C1 into x to the power 1 is just x. So what will remain? The remaining starts from n is equal to 2. So n is equal to 2 to infinity n Cn x to the power